Hello everybody, this is another example of applying the extended Euclid algorithm for a equal to 85 and b is equal to 37. So here I will go a little faster than the previous one. So we fill the first two lines with the values of a and b in the hierarchy column, then initialize u and v according to what we've seen before. So just for an example here, first step, that is calculating line 2. The quotient is 2. 2 times 37 is 74. So the remainder here is 11. So we have the value of Q2. Then we calculate U2 as 1 minus 2 times 0, which is 1, and 0 minus 2 times 1, which is minus 2, and here 85 minus 2 times 37, which is equal to 11. As the remainder is not equal to 0, we go on and calculate the Euclidean division between 37 and 11, so that the quotient is now 3. U3 is 0 minus 3 times 1, which is minus 3. V3 is 1 minus 3 times minus 2, which is 7. R3 is 37 minus 3 times 11, which is 4. 11 divided by 4, the quotient is 2. So U4 is 1 minus 2 times minus 3 is 7. V4 is minus 2 minus 2 times 7, which is minus 14. It's minus 16. Then 11 minus 2 times 4 is 3. 4 divided by 3, the quotient is 1. Then it's minus 3 minus 7 is minus 10. And here it's 7 minus 1 times minus 16, which is 23. And the remainder here is 1. So last step, 3 divided by 1, the quotient is 3. So here it's 7 minus 3 times minus 10 is 37. Here, minus 16 minus 3 times 23, which is minus 69. Minus 69 minus 16 is minus 85, and 3 minus 3 times 1 is equal to 0. So the algorithm is over on line 6. So we have the results that appear on line 5, where U is equal to minus 10, V is equal to 23, and we also know that the GCD of 85 and 37, which is in the hierarchy column, is equal to 1. So we can once again check that minus 10 times 85 plus 23 times 37 should be equal to 1. So here it's minus 850. Here 23 times 37, actually you can do the calculation by yourself, but the result is 851. So this one you can check is actually equal to 1. So that's how we can check that the calculation is okay. Now, some things to check that the calculation is going okay. You can check during the calculation that things are going right. So perhaps what you can note is that apart from the first two lines, the UK and VK coefficient in the same line have opposite signs. One is positive, the other is negative. So if in your calculation on some line you find two coefficients that have the same sign, then the calculation has gone wrong. So you can stop and start again. If one of the coefficient is 0, then the calculation also has gone wrong. You can also note that in the UK and VK columns, always apart from the first two lines, actually the sign of the coefficient is switching from one line to another. So for example, in the U column, you have from line 2 positive, negative, positive, negative, positive, and same thing for V. So if at any moment you have in the UK columns two coefficients that are positive or both negative on two following lines, then the calculation has gone wrong. And last advice about checking if the calculation is going well, you can see that the absolute values of the coefficients in the UK and VK column is growing up. So the absolute value here is 1, 3, 7, 10, 37. Same thing for the V column. And in the RK column, actually, the values are decreasing so that you always can reach a 0 at the end. So here are a few advices to check if your calculations are going right or wrong. And if they're going wrong, then you can immediately stop and start again in order to get the values of U, V, and the GCD of the two numbers you're applying this algorithm to.